For number 15, it says to simplify and reduce if necessary. So we are going to do a factor tree for 300. Okay, I can break it down by 10 and 30. 10 can break down to 2 and 5. 30 can break down to 3 and 10. And then 10 can break down to 2 and 5. So at the end of my branches, I have 2 2s. I have a 3 and 2 5s. I circle my pairs. I take 1 2 from here and 1 5 from here, and I multiply those together. The leftover 3 goes inside of the radical. For number 16, these are both perfect squares. So the square root of 25 is 5, and the square root of 100 is 10. But the directions say reduce if necessary, and that can reduce to 1/2. Okay, number 17, 18 over 121. So the square root of 121 is 11. But since 18 is not a perfect square, I do need to break it down. So we could use 2 and 9. And that goes to 3 and 3. So at the end of my branches, I have 2, 3, and 3 with a pair of 3s. So that would be 3 radical 2. In number 18, we have 40. And 40 breaks down to 4 and 10. But 4 can go 2 and 2, and 10 would go 2 and 5. So here I have 2, 2, 2, 5, x, 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 x. So I have 6 x's right here. So I did 6 x's. So now I'm going to find every pair I can. Okay, so now outside is my pairs. I have a 2, x, so x times x times x is x to the 3rd. And then my leftovers, I multiply those and put them back into the radical. So 2 times 5 is 10. Okay. For number 19 and 20, choose the type of function best models the data. So first, I check my x column, and I have a consistent pattern, increasing by 1 here. So now I check the y column, and I figure out what is the pattern here from -5 to -3. -1 to 1 and 1 to 3. So I'm going to start with the positives because it seems easier to start with positive. So from 1 to 3, I could multiply by 3 or I could add 2. I'm going to try adding 2 first to see if it works here. So -1 plus 2. Does that get to 1? Yes, it does. Okay. -3 plus 2. That gets to -1. And -5 plus 2, that gets to -3. So since I added the same number, add same number, okay, then I'm going to be picking linear. Okay. For number 20, for this one, we were going to go from 0 to 1.5. That's going to be an increase of 1.5. Okay. If I think about multiplication, 0 times 1.5 would be 0. So if I were to multiply by 0, everything's 0. So I can't multiply or divide here. Okay. Now, from 1.5 to 6, that's an increase of 4.5. Okay, we can put a little plus. Increase of 4.5. I get that by taking 6 minus 1.5, and that gives me the 4.5. Okay. From 7 to 13.5, that's also an increase. But to get the number, I take 13.5 minus 6, and it gives me 7.5. It's like working backwards. So 6 plus 7.5 gives me 13.5. Okay, and then lastly, if I subtract these, we get 10.5. Okay, but as we can see, we don't have a consistent pattern all the way down. And so we have to try for a second row of pattern, like a column here. I'm sorry, not row, column. So from 1.5 to 4.5, that's an increase of 3. And if I don't know that, if I can't figure that out in my head, you take 4.5 minus 1.5 and see what that gives you, which is 3. Then I tried it here, 7.5 minus 4.5. That's an increase of 3. And then 10.5 minus 7.5, that's an increase of 3. Okay? Now, because this number, so the second column is same number added, this would be a quadratic. Okay? But I also think you need to see an example of an exponential function, so we're going to also just do a quick example. So from 4 to 8, we could either add 4 or we could multiply by 2. So let's try multiplying by 2. 8 times 2 is 16. 16 times 32 is 2. Sorry, 16 times 2 is 32. 32 times 2 is 64. Since we multiplied, that would be exponential. So since we are multiplying by the same number, it's exponential. Now sometimes you would be dividing. So if the numbers were reversed here, like 64, 32, 16, 8, and 4, you would be dividing by 2, and that's still exponential. So if you are multiplying or dividing by the same number, it's exponential.